So as I mentioned from last video, in this class, we want to focus more on the techniques. So for chapter 3, we're going to focusing on more advanced techniques on the integration. The sections 3.1, the first section, is talk about integration by parts. So what is integration by part? Earlier, when we first introduced the regular antiderivative or integrations, we talked about some basic one, like the power rule, like the trig functions, like the exponentials and logs. We do have one technique called the substitution, and then we know that the substitution is helping us to deal with a derivative, follow the chain rule. So we want to reverse the chain rule process for the derivatives. Now, for the derivative process, we not only have chain rule, we also have product rule. So that is the integration by parts is trying to do. So let's say we have a function h of x, which is a product of f of x and then the g of x. To find the derivative, according to the product rule, we're going to find the derivative of the f times the original g plus the derivative of the g times the original f. Now, when we give you if we want to integrate, finding the antiderivative of the h prime, then we need to find the integration of the both things. Normally speaking, we probably cannot really see integrating something plus something. So what we're going to do is more like something like h of x, which is the antiderivative of h prime, is going to be the integral of f prime g dx plus the integral of g prime f of x dx. Then if we want to solve one of the integral, say we want to solve integral of f of x times g prime of x dx, which is this one, I can just simply subtract the h of x minus the integral of f prime g dx. Oh, you probably say that that's a lot of things to memorize it. So we want to do it, we want to call the integration by parts. So we're going to make it a little bit simple. Let's say that u is going to be representing f of x, v is going to be representing g of x. So the h of x, which is going to be the u times v. And also du is going to be f prime of x dx. dv is going to be g prime of x dx. Now with some simplification, moving things around, this formula now become to a final formula that if I want to integrating u dv, u dv is equals to u times v minus the integral of v du. v du. And that is our formula for the integration by parts. Then for any single problem, what you need to do is you need to figure out from your original problem, what is your u and what is your dv from the original problem. Then when you're solving them, you're going to start to figure, okay, for the u, you're going to take the derivative. For your v, you're actually going to integrate it. So this one, you take the derivative, and this one, you take the integration. And then you're going to plug back in to the u times v minus integral of v du. So because of we're going to evaluating, like at the end we're going to put it back, evaluating this part. So when we try to find the v du's, we do want to make sure this combination, it is an easier way to find the integral. At least it's going to be easier than the original one. So we have some techniques to choose which one to be the u and which one to be the dv. Normally we call it, it's not always going to be work, but it works for most of the time. LIATE. So that stands for, if we have a logarithmic, we're going to using the u to be the logarithmic first. And then if we do not have logarithmic, but if we have inverse trig, that's going to be our second option for the u. If not, then if we have algebraic function, like polynomials, things like those, then that's going to be our third one. And then the fourth order is going to be the regular trig. And then the lastly is going to be the exponent. And that is our choice for choosing the u. In the next video, I'm going to show you some examples on how to use the integration by part to solve some of the problem.